Okay, this is a really interesting problem. We are given a functional equation, right? So basically, some equations involving integrals that the function satisfies. And we also told that the function is continuous, the domain is real number, the range is real number, and yeah, x belongs to R, right? And we have to solve for all such function that satisfies this condition, this equation, right? How we'll try to do is, because there's this integral, we'll try to differentiate and maybe try to get a sort of differential equation that can help us solve for the function. So that would be our approach. Let's see how it goes. So yeah, we are given this, right? So first of all, what I'm trying to do is, because there's this x minus t in the input of f. So let me try to use King's rule to simplify this. So basically King's rule is just kind of a substitution that says this integral will be equals to f of a plus b minus x dx. So I have already proved this in my earlier videos, so you can check on my channel. But for now, let me just use this. And if I use that, I can actually simplify my integral a little bit. Because now I can actually write x plus 0 minus t over here. And this actually simplifies a lot. Because now this is x minus t, so x cancels out and just becomes f of t. So f of minus x now becomes 1 minus 2 integral from 0 to x e to the power minus x e to the power t, and then this is f of t dt. So we have f of minus x is equals to 1 minus 2 e to the power minus x integral from 0 to x e to the power t f of t dt, right? Okay, how do we proceed ahead? Now, just as I told, I will try to differentiate this with respect to x. Okay, and over here, let me tell something about this. So over here, we have integral from 0 to x of some function f of t dt, right? And I'm trying to differentiate this with respect to x, right? If I integrate this, what I will have is basically, let's say the integral of f is capital F, the indefinite integral of f is capital F. So I will have capital F of x minus capital F of 0, right? If I differentiate this, I will just have f of x minus integral of, so derivative of constant is 0. So I will just have f of x, right? So we see that the derivative of this integral will just be f of x. So yeah, just keep that in mind. It will be helpful later on. So here, if I try to differentiate, there are two functions of x. So we will be using product rule. And that gives me f prime of negative x equals to, this equals to 0, and then negative, okay, first of all, if I differentiate it to the power negative x, I will have negative sign. So that makes it's positive, right? And then after that, I will have negative 2 e to the power negative x, and then this will just be e to the power x f of x, right? Okay, so then I will have f prime of negative x is equals to, okay, over here I will do one thing. I can actually substitute this as 1 minus f of minus x. You can actually see it from here. From this equation, you can actually like isolate this term and get it as f1 minus f minus x. I'm doing this so as to obtain a sort of differential equation where all of them are just y, right? Yeah, so I'm trying to do that. And this becomes just minus 2fx. So we just have fx now, and that's really nice, right? And to simplify it even more, I can actually can I do anything more? No. Okay, so what I'm trying to do is, oh wait, when I differentiate, there's negative sign, I forgot that. So now what I can do is, I can write it as 2f of x plus f of minus x minus 1. Yeah, I'm taking this negative sign to other side. So now, let me just take, let me just, let me just make x to negative x, right? So that this just becomes x, and then 2f of minus x plus f of x minus 1. Okay, good. Now, what I can do is I can again try to differentiate this. right? So that I'm doing this just because if to see if I'll be able to eliminate this negative x so that all of them are just function of x, right? And turns out I will be able to. If I differentiate this again, I will have negative 2f of negative x plus f prime of x, right? Now, uh, now if I try to substitute f of negative, sorry, there's, this is prime because I'm taking derivative of this expression. This is prime, right? I'm sorry. Okay. Now if I try to substitute f prime of minus x and f prime of x, turns out these two terms will cancel each other. These two terms will cancel each other. And that's pretty nice. So let's see. So f double prime of x is equals to negative 2 times 2f of x plus f of minus x minus 1 plus f prime x is 2f of minus x plus f of x minus 1, right? So we'll now have f double prime of x is equals to negative 4, negative 4f of x, negative 2f of minus x plus 2 plus 2f of minus x plus f of x minus 1, right? And then this cancels out. So now this has simplified a lot. F double prime of x is equals to, this is negative 3f of x plus 1. Now I can further simplify this as f double prime of x plus 3f of x is equals to 1. Now this is just a differential equation, right? Now this is just same as solving y double prime plus 3y is equals to 1, you know? Okay, but now we also need initial conditions, right? So for that, I can actually find it out from the given things. So but here, in this first equation, okay, so let's say in this equation, over here, if you try to substitute x as 0, what do we get? F of 0 is equals to 1 minus 2, and the integral from 0 to 0 of something, right? The integral from a to a is just 0, so this is 1 minus 2 times 0, so that's just 1. So f of 0 is 1, right? Okay, so we got one initial condition already. F of 0 is just 1. Now let's try to find f prime of 0. So there's this equation. Let's try to use this equation again. Or we can also use the second one, but it doesn't matter. If we substitute x at 0, f prime of 0 is equals to 2f of 0 plus f of 0 minus 1, right? F of 0 is 1, so this is 2 plus 1 minus 1, so that's just 2. Wow, we also got another initial condition so easily. That was not at all hard. So now that we have it is, okay, so now know that all the functions, basically all the functions that satisfy the criteria, this criteria that is given, will also satisfy this criteria, right? Because these are just derived from the ones given. And we know that all the functions that satisfy this given criteria, basically this is a second order constant coefficient, like linear differential equation, right? And we know this has a unique solution. This has just a single unique solution, right? So that means if we find out that solution, that's the only solution that is satisfied, like that this equation is satisfied by. So then we will be pretty much done, right? So just find that one solution of the second order differential equation and we are done. That's it, guys. So, okay, to solve it, first of all, we will solve the homogeneous part, which is basically y double prime plus 3y is equals to 0. And we know if you just use the characteristic polynomial, you will find that the solution will be c1 and then this is root 3, right? So so this becomes root 3. Actually, characteristic polynomial is r square plus 3 equals to 0. So this will be r is equals to plus minus root 3i. So that means solution will be cos root 3t and sine root 3t, right? Yeah. So that means c1 cos root 3t plus c2 sine root 3t, right? So this is this answer for the homogeneous part. And now for the particular solution, we need to satisfy y double prime plus 3y is equals to 1, right? Okay, since there's a constant on the right hand side, y should be some constant. So basically, notice that if I choose y p is equals to 1 over 3. This just goes to 0, and 3 times 1/3 is just 1, right? So yeah, this is the particular solution. That means our solution will be c1 cos root 3t plus c2 sine root 3t plus 1/3. But we also have like the conditions, right? Okay, so if I use the first condition, I will have 1 is equals to c1 plus 1/3. That means c1 will be 2/3, right? If I use second condition, I will have y prime is equals to negative root 3 c1 sine root 3t plus root 3 c2 cos root 3t, right? Now if I again use this second condition, I mean y prime of 0 is equals to 2, I will have 2 is equals to root 3 c2. So that means c2 will be 2 by root 3, right? So now we have c1 and c2. So we can say that f of x is actually 2 by 3 cos root 3t plus 2 by root 3 sine root 3t plus 1 by 3. And that's a pretty elegant solution. So that's the only solution, guys. Maybe you can just break them. You can just say that this is also a solution, this function is solution, this function is solution. You can also say that. But as a whole, their sum is also solution. And that's the answer, guys. So we have solved it. So we have seen how like we can actually change a functional equation like this to a differential equation and solve it, right? And that's beautiful. Hope you enjoyed the video. Thanks for watching, and I look forward to seeing you in the upcoming videos too.